Welcome back to the video lecture series for Introduction to Data Programming using Scala. In the last video, we started talking about the combinatorial parser, parser combinator that's available in Scala, and saw how we could build a grammar and convert it to a Scala form. But we didn't actually use that grammar to parse anything. In this video, we want to take that next step, and we want to look at the default output of these parsers. So this was the code that we had written last time. We started with this grammar, which is used to represent simple formulas that involve the four operations of addition, subtraction, multiplication, and division. And we converted it into this form using this Scala parsing library. And we pointed out that these two are very similar. Okay, so if you can write a general context-free grammar for what you want to do, you can inevitably create a parser combinator for it. Now, we want to see what this produces. So we're going to put a main in here. And inside of the main, we are going to parse what we just, something with the parser that we just wrote. So we'll go ahead and print out some output. And the output that what I want to print, so I want to call parse all on using one of our parsers. I'm going to pick the parser for form and then pass it a string. So a simple example would be 2 plus 3 times 5. And if we run this, you can see that we get this output. This is actually giving us the parser. If we want the any value that was inside of it, we can call .get. And now this is just the result. Now you might be wondering, what the heck is that? What exactly did this produce for us? And the answer is, well, there's a default output that is produced by these parsers. So there's default outputs for each of the different pieces that we have in here. For example, the tilde that is in there, when something matches on the two sides of a tilde, the output that we get from it is a tilde. And when it prints now, technically, so in a certain sense, the two tilde empty list there is tilde of 2 comma list, but it prints it out by putting the tilde in the middle. Okay? And so this right here says we have a 2 and a list. If you get all the way down to something that's just a string or a regular expression, you get back that string or regular expression. So this is a string, this is a string here. The plus will match a plus, which is, and the times will match time. That's why we have a times there and a plus there. Those are actually strings. We talked about what the tildes do. What about these lists? Well, so why is there a 2 tilde list here that's empty? Turns out the lists are what we get from rep. So rep gives you back a list of all the different things that were part of that repeating. In this case, this says that there is a 2 tilde and an empty list. So what happened here, now you might be like, well, but the 2 is plus. Yes, it is. So this whole set of parentheses right here is what we got for this first term. And then it's tilded with the rep. And so you'll note over here, this is a list of plus, and then a tilde, 3, etc. So this part in here was what the term was able to produce. So the term produces a factor followed by a tilde and a rep. It's this rep right here that is the empty list in this case. And the factor is the 2, which winds up matching on a floating point number, which is a pre-programmed regular expression for us to help make this so it's easier. And so then the stuff on this side of the tilde over here is what we got from this rep. And so you'll see that it's a list, and it's a list that actually only has one item inside of it. It's a tilde with a plus and then another term, and that term is that right there, which happens to be a 3 tilde, and then we get a list with one element. So this here, so the plus goes, we have to wind up going down to the multiply because this is what's producing this list. Now, this output isn't necessarily what I want. We actually can write a function that will go through and walk this like a tree. So, for example, eval. Do I want to evaluate, or how about I just walk? Walk default output. We're going to take an any. Notice this was a parser of any, and the reason is because this winds up returning. It can return a list. It can return a tilde. It can return a string. There is no common supertype for all of those things, and that's why this needed to return the any in here. I can make this walk it by, let's go ahead and put an equal sign, a match. Well, so there are different possibilities. One, case s string. If it's a string, how about I just print out s? If it is a tilde of ab, that's a pattern there, so the tilde joins two things, and I want to do each of them. Then I will recursively call this on walk default output on A, and then do the same thing for B. Because I've made this recursive, copy, paste, do it for B, and then I also have the case of a list let's go LST is a list of any, in which case LST for each walk default output. And if I called that, instead of doing a print line, let's call walk default output, and then run this. Oh my goodness, notice what it prints back out. It printed out the original string that we had, but after going through the whole act of parsing it and generating that intermediate form, this winds up walking back through it, and it can reconstruct it. Had this had parentheses around it, right now we are not well, that's interesting. Okay, like that had to. Okay, because the parentheses are in here, they're strings. We're printing out strings. Everything is happy. What about evaluating this? What if I wanted this so instead of returning a unit, it returned a double? Well, things get a little bit harder in that case. I would return s dot to double for this. If it were a tilde, well, I don't really know what to do with tildes, because tildes can separate all types of things in here. It really depends upon what's next inside of the list. The form that it gives us is not something that I can easily do an evaluation on. Okay, so what can we do if we want to evaluate this? Well, that's where we're going to come back in the next video, and we're going to talk about how we can change the default output so that instead of Let's go ahead and preserve our print line there. Instead of having it return this, we can return something that is closer to what we actually want to work with. And indeed, we're going to return a tree-like structure just like we did with our recursive parser for formulas earlier. So that's it for this video, and we'll come back and look at how we can change what this outputs in the next video.